Hello, Professor. Today we are going to discuss about the assignment 3, and I'm going to solve the problem 3.1.26, 3.2.5, 3.3.8 and 3.4.2. This chapter provide us the basic understanding of model fitting and also provide us the understanding of implicit models versus predictive model. And we also find out the kind of error that occur while doing the modeling. In first set of problem, we learn how to model original data and transform the data graphically, and then draw the conclusion about the adequacy of the observed model. In the second set of problem, we learn about different analytic method of model fitting, such as different analytic methods of model fitting, such as least square criterion, and how to apply least square estimate to fit a straight line or power curve and choose the best model. The next is problem identification. In the first problem, we need to test the model Q equals AE power BX by plotting the original data and transform the data. Based on the plot, where the point on the graphs are arranged in a sequence from which a line can be formed, we would draw a conclusion about the adequacy of the model and evaluate the unknown parameters. In problem 3.2.5 is to recover the value of x1 using the linear program. x1 is unconstant and can assume any real values. x2 and x3 are constant and can assume values greater than equal to 0. And we need to figure out different situations to recover the value of x1 using the constant x1 equals x2 minus x3. Problem 3.3.8 is related to apply the least square criterion and estimate the unknown parameter by using the equation 3.5, 3.6. In order to use the equation 3.5 and 3.6, we would need to generate a table from different parameters such as x power 2, xy, x power 4, and then use those parameters in model ABC to estimate the unknown parameters. In problem 3.4.2, we would need to construct a model P equals AV power B for the given data using the method of least square. We would need to transform the data and then apply the normal equation to predict variable A and B, and then find the sum of square deviation to compute the D. Let's see the code. In this code, first we are plotting the values using the given data which we can see in the list Q and list X. List X is represent the different time point and Q represent the corresponding consumption. Then we create a plot with regression line. From the data we can see that Q and X has exponential relationship. So to solve the model, we apply log of Q over different time point, as you can see in the output. Then we can create a plot with regression line. As you can see, after transforming the data, we can get the straight line which suggests that the model is suitable to predict energy consumption. Then we can take any 2 points. And calculate the slope. Any 2 point you can see here, and the slope is 0.07, and log of A is equals to 0, hence A equals 1. For this problem, we have created a simple program here with 6 different values of greater than equal to 0 for x2 and x3. Then we run a loop to calculate the values of x1 using the linear program. x1 equals x2 minus x3. When we run the code, it will arise 3 situations. The first is x2 greater than x3 greater than equal to 0. Then x1 greater than 0. The second situation, x3 greater than x2 greater than equals to 0, then x1 less than 0. x2 equals x3 greater than equals to 0, then x1 equals 0, and which we can see in the output as well. Problem 3.3.8. In this problem, we need to apply least square criterion on different model. In order for us to do that, we need to calculate different parameters. Row 5 to 10, row 5 to 10. We are just creating some variables that we'll use later in the code with initial value equals to 0. List x and y are given data in the problem. Then we run the loop for the values of x and y and calculate xy, x square, x4, x square, y. You can see the values in the output. We are also calculate the sum of xy, xx, x square, x4, x2, x square, y in the same loop. We can see the values of all the sums in the output. Then we solve the model. The model 1 is y equals ax. In the model, we need to resolve the value of a using the least square criterion. If we follow the formula given in chapter 3.2, we arrive at formula a equals sum of xy divided by sum of x square. If we apply the formula, we get the value 3.7, which we can see in the output. The model now is y equals 3.7x. Then we will solve the model 2. Y equals b plus ax. In this model, we need to solve the both a and b. If we follow the equation 3.4, 3.5 and 3.6 in the chapter, then we come up with the following model to predict a and b. After applying the model, we get a equals 4.06 and b as minus 25.40. So the model is y equals minus 25.40 plus 4.06x. And the same way we will solve the model 3, which is y equals x square, ax square. If we solve the equation, then we get a equals 0.044. So model will read y equals 0.044x square. Problem 3.4.2 is also a problem of least square criterion. We create some list variable and assign the initial value of 0 to them. Similarly, we create some additional variable with the initial value of 0 to calculate the sum. We are creating list V and list P of given data and plotting them with the regression line, which we can see in the output. As you can see from the output data, the data is quite scattered. In order to put the data in a model and calculate the deviation, we need to calculate some parameters. As you can see, we create multiple parameters and their summation as well. As you can see in the values in the output, we create another regression plot using the transform the data. And then we use normal equation to resolve the model P equals AV power B. After resolving the normal equation, we get the value of A equals minus 0.107 and value of B equals 8.02. We use A and B to get the sum of square deviation that you can see in the output. Then we apply the formula D equals D2 plus D3 until D11 and divided by n, which is 15. And if we do, we get D equals 0.401 as an answer. And in the conclusion, we learn about different model techniques in the chapter, but finding the best model can still be daunting task. We need to evaluate each model on a case-by-case basis. Thank you.